Consider a car moving with an initial speed v. The coefficient of kinetic friction between the tires and the road is mu. If the driver hits the brakes suddenly and the car skids, it takes time t for the car to come completely to rest, and the car travels a distance big D while skidding. State how time and distance would change in each of the following cases and explain your reasoning. The initial speed of the car is greater. If the initial speed of the car is greater, it's going to take longer for the car to stop, both in time and displacement. Give me a second, let me type all that up. There we go. T and D are longer. Brakes take away some velocity each second. So more velocity means the brakes work longer. Next up, the coefficient of kinetic. What happens if the coefficient of kinetic friction is greater? If that happens, then T and D are shorter because friction takes away some velocity each second. More friction means more velocity taken away each second. So it happens quicker or shorter. All right. I think that's enough typing for now. Anyway, let's see. On the dot, represent the car. Draw and label the forces acting on the car while the car is in the process of skidding. Well, if a car is in the process of skidding, we know that it's slowing down, right? So here we go. We have mg, or F sub W. That's 1, 2, 3, 4 down, 1, 2, 3, 4 up, and that's Fn. Okay? There's nothing making it go, so we have frictional force, the frictional force acting in this direction. There's nothing to indicate a specific magnitude here. It's just you should have only frictional force acting. Okay. In the space below, derive an expression. Yes. Derive an expression. That means we get to take an equation that's given to us on the equation sheet and then just show the steps to relate it to this specific problem. Free points here. Free points when you see derive. Okay. So let's see. Equation that's given to us. We know frictional force here equals mu Fn. And in this case, we're skidding, so we're sliding. So this is mu K. If we were not sliding, if we were just rolling along, then it would just be mu S. So we know frictional force equals that. And we also know, if we have a free body diagram, use Newton's second law. Stuff that makes it go minus stuff that holds it back. So stuff that makes it go, there's nothing. So we have frictional force equals mass times our net acceleration. Express the magnitude of the car's acceleration. Perfect! Perfect! So all we have to do is just unpack this, which is mu K Fn. We already know that. That's a K right there. Yeah. Mu K Fn equals M A N. Feel like we can go a little bit further because we know Fn is just our mass times acceleration due to gravity. So we have mu K times mg equals ma. That's the net acceleration. That's where the n is. It's not a thing. Now we have an m on each one. So we have acceleration equals negative mu k times g. Cool, right? We're slowing down. That's what the negative is representing. And it's times g. We have answered the question, which is asking us for the acceleration. We said whenever we see derive, that means we're going to take equation that's given to us, that's this one, and connect it to our situation. So we took our situation. We have a free body diagram, so we know to use Newton's second law. And then we just went through the steps one by one. That is the process of deriving. I didn't just say negative ff equals ma, so a equals f over m. No, that's not what we end up with here, right? the acceleration equals mu k times g. So we need to show this process, each specific step. Guess how you're going to get better at that? Just guess. Use your answer from part B along with an appropriate motion equation to derive an expression for t. All right, so t, what do we have? That's the end of... Uh-oh. I've got class. I'll be back. So for t, we know we have the velocity. We know we have mu. And we know we have the acceleration due to gravity. All right, so looking for time. Velocity has time with it, right? Velocity. Let me give the full equation here. Acceleration equals delta v over delta t, right? Moving this around, we can solve for velocity to get velocity equals acceleration times time. We know what acceleration is. We just said earlier it's negative mu k times g. So we have negative mu k times g times t equals velocity. And then rearrange this equation to solve for time. Divide mu k times g from each side, and we get t equals v over mu k times g times t. There we go.